Okay, in 4.1, we are going to be looking at absolute value functions, well, in unit 4. So today in 4.1, we're going to start with solving absolute value equations. So just starting off with some definition and some understanding of absolute value. Absolute value, which is represented by these two vertical bars, determines the positive difference between a number and a reference point h, so that the absolute value of x minus h, what this means is just the distance between x and h. So keep in mind, distance is always going to be positive. So what this means is that the absolute value of 5 is just the distance between 0 and 5. So the distance between 0 and negative 5 on a number line, 1, 2, 3, 4, 5, is 5 units. So that means that the absolute value of negative 5 is 5. And that the absolute value of positive 5, again, meaning how far away is it from the middle, 1, 2, 3, 4, 5 units. So the absolute value of a positive 5 is also 5, because we're just determining the positive difference from a reference point, in this case, obviously from 0. So now let's talk about it algebraically. Starting with this first example, I've given you the absolute value of x is equal to 3. So what this means is the distance between x and 0 is 3 units. So if you're looking at 0 on the number line, 3 units to the left is negative 3, and 3 units to the right is a positive 3. So therefore, we have two solutions because there's two values that could be plugged into these absolute value bars. That is both x equals negative 3 and x equals positive 3, because both negative 3 and positive 3 are 3 units away from 0. So our solution to this equation, since it has two solutions for x, we're going to write this as a solution set, and we're going to use our little curly brackets, and we will put these in order from least to greatest, negative 3, positive 3, and then end with those curly brackets again, since it's a distance. Or a set, I'm sorry. I've given you another example. Example 2, we're solving the absolute value of x minus 4 equals 3. So what this would mean is the distance between x and 4 is 3 units. So now our reference point is going to be 4. So we're looking at what are the values that are 3 units away from 4. And there are two options here because we could go left or right. So if our reference point is 4, 3 units away from that would be 1 on the left, and then 3 units away from that on the right is 7. So those are going to be our two values that we could plug in for this x that would still make this absolute value equation true. If I plug in 1, 1 minus 4 is negative 3, and the absolute value of negative 3 is 3. And if I plug in 7, 7 minus 4 is 3, and the absolute value of 3 is 3. So that is how we get two different solutions for x. So our two solutions for x are going to be 1 or x equals 7. And so because, again, we have two solutions for this equation, we would write our solutions as a solution set in order from least to greatest using those curly brackets. All right, one more example here, just kind of explaining absolute value. This time we're solving the equation, the absolute value of x plus 5 is equal to negative 1. Remember what we said in this second bullet point up here. Distance is always positive, and absolute value is talking about a positive distance. So, in this last example, what this is saying is that the distance between x and negative 5 is negative 1 units. And absolute value cannot be negative. So this type of equation would have no solution. Again, because distance is always a positive number of units, regardless of whether you go left or right from your starting point. So anytime you see this absolute value is equal to a negative, there is going to be no solution to that, because absolute value represents distance, and distance is always positive. So now that we've done a little bit of review of what that is, we're just going to review how to solve absolute value equations. So I've given you guys your 3 steps here, and then an example problem on the right that we will work through as we go through each step. when you're solving these equations, the first thing you need to do is isolate the absolute value expression on one side of the equation so that it's in this form, x minus h is equal to c. So in the example on the right, you will notice that the absolute value part of our equation is not by itself. It has this coefficient. So the first thing we want to do is get rid of this coefficient. The absolute value bars are not parentheses. You do not distribute. Absolute value bars, you cannot distribute. So instead, we're going to use inverse operations to get rid of that 3. Since the 3 is being multiplied by the absolute value, we'll divide. And just like any other equation, whatever we do to one side, we have to do to the other. So then what we'll be left with here is the absolute value of x plus 2 is equal to 4. So now we have it in this form. We have just the absolute value bars set equal to a number, and this number is positive, so that is good. So then what we will do next is we will split the absolute value equation into 2 equations, because remember there's going to be 2 values for this x. We're going to set one of these equations equal to this positive c, which is the positive 4, and then we'll set our second equation equal to the opposite, which is negative 4. So we will do x plus 2 equals 4, and x plus 2 equals negative 4. And now that we've split it into those 2 equations, we can just solve each equation. So to get x by itself, we're just going to do the opposite of a plus 2, which is subtract 2, which means x equals 2. But then our second equation, we're still subtracting the 2, but when we do this time, we're subtracting it from a negative 4. So the negative 4 minus 2 is going to give us the solution of x is equal to negative 6. So that is our solution, meaning we can write our solution set as x is equal to negative 6 and 2. And if you go back and think about what we talked about even up this top part, there are from 2, you're going to go left or right and find that difference of 4. So if I plugged in negative 6 here, negative 6 plus 2 is a negative 4, which the absolute value of that is 4. And then if I plug in 2, 2 plus 2 is 4. So the absolute value of that is also 4. All right, let's look at 3 more examples here, practicing solving these equations. Starting with number 1, we have the absolute value of 3x minus 1 minus 10 is equal to 0. So again, step number 1 is we need to isolate this absolute value part. So on the left side of this equal sign with that is a minus 10. So we'll undo that minus 10 by adding the 10 so that that cancels out. So that we're left with the absolute value of 3x minus 1 is equal to 10. And now that we have this absolute value bar isolated and it is equal to a positive integer, we're going to go ahead and separate this into 2 equations. And one of them is going to be 3x minus 1 is equal to 10. And then the second one is going to be 3x minus 1 is equal to negative 10, the opposite of that. And now we have 2 very easy equations where we can solve for x here. So we will add the 1 to get rid of that constant. So then I have 3x is equal to 11. Then I divide by 3, which means one of my solutions for x is 11/3. And then if I add 1 to negative 10, well, that gives me negative 9. And divide that by 3, and x is equal to negative 3. So now you have found your 2 solutions for x, and we can write them as a solution set where x is equal to negative 3 or 11/3. Those are the 2 possible options that we could plug back into our equation and this be true. All right, let's look at number 2. Number 2, we have 9 minus the absolute value of 2x plus 5 is equal to 13. So again, we've got to get this absolute value bar by itself. So the first thing we're going to do is get rid of this constant. So we would subtract the 9 from both sides. Now, when we subtract the 9, we still have this negative out in front of the absolute value bar. So we need to bring that down so that we have the opposite of the absolute value of 2x plus 5 is equal to 13 minus 9 is going to be 4. And so these absolute value bars are still not isolated, which means I need to get rid of this coefficient. This coefficient is like a -1. So to get rid of that, we're going to divide by a -1 so that it cancels out the negative sign. So that we have the absolute value of 2x plus 5 is equal to, when I do 4 divided by -1, I get -4. Now, right here is when sirens in our heads need to be going off, because absolute value is equal to a negative integer, but absolute value represents distance, and distance can never be negative. So at this point, you do not need to go any further. There is no solution to this, again, because absolute value cannot be negative. So there will be nothing that we can plug in for x that will ever make our absolute value negative. There's no solution. And one more example here. I have -8 times the absolute value. Okay, sorry. Again, number 3, we have -8 times the absolute value of 8x minus 2 plus 4 is equal to -116. So we need to isolate this absolute value. Right now it is equal to a negative, but we cannot make any decisions about whether or not there's a solution until we have the absolute value bars isolated. And then if it is equal to a negative, then it's no solution. But right now we have these extra constants and coefficients that we need to move over first. And when you do, we're going to undo the constant first, just like we always do when trying to isolate a variable, or in this case, the absolute value bars. So then we have -8 times the absolute value of 8x minus 2 is equal to, when I do this subtraction, -116 minus 4, I get a -120. And then now, to get the absolute value bars by itself, we're going to undo this coefficient. So we divide by -8. And what you'll notice is when we divide by -8, -120 divided by -8 now gives me a positive 15. So now we do have our absolute value equal to a positive integer, which means we can find solutions for x. So then from this point, we'll go ahead and split, and we will put one equation equal to positive 15, and then we will write it again, 8x minus 2, but then this time we'll set it equal to a -15. So we will add the 2 to 15, and we get 8x is equal to 17. And then divide by that coefficient, and we'll just leave this as 17/8. And then when we add 2 to the -15, well, now we get 8x is equal to -13. And then we divide by that coefficient 8. And again, we'll just leave this as -13/8. So we were able to find solutions for x here. And since there are 2, we will write them as a set. So x is equal to a -13/8, then or 17/8. All right. So again, with solving these absolute value equations, the steps are there, but the first thing you want to do is just isolate the absolute value bars. using those inverse operations. And then once you have the absolute value isolated, you're just breaking it into two equations, one set equal to the positive, one set equal to the negative. Find the two solutions for x, and that is it. All right.